Matrices have different operations, including multiplication. In this lesson, we're going to learn about some of the operations as well as talk about identities and inverses. The first operation is matrix multiplication. And to do this, what you're going to remember is multiplying the rows of the first one by the columns of the second one. Meaning, if I were to look at this, these matrices, rows go this way, and columns would go down. This is rows by columns. And so when you multiply, you're going to take the elements in the row here, multiply it by the elements in the row here. And that's going to give you your very first element when you add up all of those multiplications. The second row by the first column is the second row by the first column. That's going to give you this number as well. Now, one thing to know is that matrices have orders, and the order represents the row by column written down like this. So this is 3 rows by 2 columns, and this is 2 rows by 3 columns. And in order to be able to multiply, these inside numbers must match. If they don't match, you can't multiply. And the result, the 3 by 3, is what you're going to get as the product of multiplying the two matrices. Now, you also have properties of matrices. Notice that you can group them differently. You can multiply by scalars. You can use distributive property, but you cannot use commutative. So AB does not always equal BA. You can't assume that. Now, I'm going to go ahead and do some examples with multiplication. If I look at inverses, now inverses are going to tell me that I actually have something called an identity matrix. If you multiply a matrix times its inverse, the product is going to be the identity matrix. So if you want to check if two matrices are inverses, you can multiply them and see if you get this, but you have to multiply them in both order. A times A inverse and A inverse times A. Looking at this example, the question is are these inverse matrices or not? And so what you really have to do is find out, does A times B give you the identity matrix, and does B times A give you the identity matrix? This is a 2 by 2. This is a 2 by 2. These match, so you can multiply them and you're going to get a 2 by 2 matrix. So I'm going to go ahead and write down that matrix. Now, want rows by columns. 1 times 3 is 3. 2 times -1 is -2. Going to the next position. 1 times 3 is 3. 3 times -1 is -3. 1 times going to the next row by column, so it's 1 times -2 is -2, 2 times 1 is 2, and the very last one, row by column, is -2 plus 3. And that's going to tell you that this particular matrix is a 1, 0, 0, 1, which in fact checks out that it's going to be true. Now, we're going to do the same exact thing. I'm going to write that in the correct order so I can read it easier. B times A. And again, what I'm going to do this in my head a little bit. 3 minus 2 is 1. -1 plus +1 is 0. Now I'm going to this row and this column. 6 minus 6 gives you 0, and -2 plus 3 gives you 1. So that checks out as well. So the answer to this one is yes, they are inverses. Now you can multiply things through as well. If you look at this very first one, you can see that A times B plus C would be where you multiply these two. This is a 2 by 2 and a 2 by 3. You could actually multiply them, and your finishing product would be a 2 by 3 matrix. But I'll go ahead and do number 11. When you do 11, the first thing you're going to want to do is say that do the parentheses first. So it's B minus C. Therefore, it's going to be A, and now I'm just going to be subtracting these elements off of these elements. So -4 minus -1 is -3. 2 minus 0. -1 minus -4. 0 minus 3. -5 minus -2. 3 minus 1. And I'm looking at multiplying matrix A by that particular matrix. All right, 2 by 2, 2 by 3. The result's going to be a 2 by 3. These match, so I can go ahead and multiply them. Okay, so I'm going to go ahead and fill this in. -1 times -3 is 3. Minus 15 is -12. 3 times -3 is 9. Minus 0 is -9. Row by column. Now I'm on the second column. So it's going to be -2 minus 15 is -17. And 6 minus 0 is 6. The last one, -3 plus 10 is 7. And 6 plus 0 is 6. So the resulting matrix is that last matrix. If you don't do a couple things in your head, this can be very long and hard to follow. But once you get the hang of it, it's not too bad. Just keep thinking row by column in matrix multiplication.